Okay, hello Saman, how are you? All right, now, so we learned about the square wave thingy, and now we're going to move towards the sine wave. So let's check that out too. So actually, for a sine wave, that's right. Wave RMS. So let's look at this. So sine wave basically looks like basically this. Okay. Now that was voltage versus time. So if you look at it, this is the maximum voltage that we have, V naught, and that's the minimum voltage, which is negative V naught. And that's basically one time period t, and that's the second time period 2t, right? So what happens is that if you want to find like the square of this, if you do the square and then take the mean, basically it becomes really, really difficult because it involves integration, which is not the part of our course. We do not do calculus in that kind of depth. So what I mean by this is, now when you square something, like you take v square versus t, so the whole thing basically becomes like this. So the negative portion of the wave basically comes back on the top, because squaring just removes the negative sign. And now if you look at it, this is now v naught square, and this whole portion, like this one and the next one, this basically represents one time period. All right, and the second time period would be this. So basically what has happened is that this portion that you see and this portion that you see has flipped up with the square values, because we have taken square, and square of a negative value becomes a positive value in any case. So we can't do this, because you need to remember that to find RMS, then we have to integrate, and integration is not the part of the course, so we're just going to leave that right here. However, what we can do is to find this, so the mean square, we take mean of the square value that we get, like when we square it up, basically it will be v naught square, and then when we take mean, it will be 2, because we're doing half. All right, so to find, like, this is mean of square, and to find RMS value, so RMS means that root mean square. So what we do is we simply take root of the square values, and that's how we get the RMS value. So basically you can either use this formula, and if there is current, you can also use it for current. So IRMS would be equal to I naught squared, that's the maximum current square, divided by 2, and then you can find this. All right, so this is basically this, and I just want to tell you this is the square of max voltage. Max voltage, some people like to call it peak voltage, whatever you want to say, it's fine. And this is basically the square of max current, and that's also the peak current, really. Okay. So these two functions, basically these two are for any sine or cosine functions, and that's how we can actually find RMS voltage or current. I hope that's clear. If you have any questions, please let me know.
Sir, why did it divide it by 2?
Because we got to take mean, right? If you look at it, in one whole wave, like in one whole wave, which is the time period right here, basically V naught comes twice. It comes at this point and it also comes at this point. Do you get my point?
Yes, sir.
So we got to divide by 2 to find whatever it is. Okay. So it's the same
Okay.
thing. We are squaring it and then we're taking the mean and then we're taking the root. So that's how it just shows you this. All right. We don't need to get into how this formula comes, why we are taking to, because it called if we need integration to that, and we're not supposed to do that really. Okay.
Hi, sir. Can you just recap real quick?
Yes, Ramin, what we did was today, yes, last time we learned about this finding RMS of a square wave. Today we are doing RMS of a sinusoidal wave, right? So if you have a wave like this, so it has the peak voltages of V naught. What you do is you square it up. When you square it, the depressions basically come up, because anything that's negative, when you square it, becomes positive. Do you understand this? So
Yes, sir.
what I'm saying is that this is, if this is time period of this wave, so when this portion basically comes up, it becomes something like this, right? And then it is the same time period. So what we've done is that we have taken the mean, and because there are two V naughts, we have V naught here, we also have V naught square here. So to find the mean, what we do is we divide by 2. Understood?
Understood.
Then, because we are finding RMS means you square first, you take the mean, and then you take the root. So when we take the root of this, like V naught square over 2 under root, that basically gives us the root mean square value of that velocity, voltage. Is it clear?
Yes, sir.
And we could do the same thing for current. So that's how it is. All right. These two equations can only be used for cosine and sine, functions, nothing else. So you guys need to remember that. All right. Now I'm gonna give you basically 3 different equations. Okay. In fact, let's do, I guess, 4 different equations. And then from those 4 equations, you learn how to find the average values, and that's pretty simple. So, first of all, I'm going to give you some. You can make formulas on your own, but I just want to tell you how to make them, some common formulas. First of all, we're going to talk about, you've learned this formula in AS, that power is equal to voltage times current. Okay. Then we also learned about power equals to V square over R. We also learned about power equals to I square R. We learned about energy being equal to voltage times current times time. And one of the formulas that we always used was voltage equals to current into resistance. V is equal to IR. You guys remember this, right?
Yeah.
Now, if you want to find, suppose you want to find power average, okay, so you want to find average power in a sinusoidal wave, what you're going to do is you are going to multiply the RMS value of voltage and the RMS value of the current. Is it clear? Similarly, here we're going to find power average by RMS square voltage divided by just R, because R does not have a particular RMS, just the value, right? For this one, if there was current, to find the power average, I would say I RMS whole square multiplied by r. So that's how it is, right? Let me just put a bracket here so you guys don't get confused. So the RMS is just one symbol, okay? And then for average energy, we would use V RMS times I RMS times T, because T is just a value. And for this one, if I want to do this, so V RMS and I RMS times R. So basically what you guys need to understand is that whenever we're finding average of power energy, we are going to use the RMS values, not the regular ones. Understood? If you have any questions,
Yes,
please
sir.
let me know here. Okay, then we have a small derivation that we want to do, and from that we're going to learn a lot of things. Okay. So one of the questions which comes very often is when they say prove that the power average is equal to peak power over 2. So you need to prove this, okay? Now using these formulas, we're going to prove this. It's not very hard. So first of all, we need to know that exactly what is peak power. So peak power means that because power is voltage times current, so voltage, the maximum voltage times the maximum current will give you the peak power, okay? We also know that average power is given by Vrms times Irms. So we need to rely on these two equations to get our answer. Okay. Now let's look at this. Let's write the formula right here. We're going to say, okay, peak power average is equal to Vrms times Irms. And we also know that on the side, I'm just writing it, that Vrms is equal to V naught square over 2 under root, and IRMS is also I naught under a square under root. We can simply write it as V naught over under root 2 and I naught over under root 2. So that's easier to remember actually and write. So what I can do is I can put it right here. I can write, instead of Vrms, I can write V naught over under root 2 times I naught over under root 2. You guys agree to this? Please check if you have a question. Okay. Now we can multiply V naught and I naught together, and this will be under root 2 into 2 is 4. So you guys can guess that basically V naught and I naught will be under root 4 is basically just 2. And if you look closely now, that this V naught and I naught is right here, which is equivalent to peak power, which means the average power is equal to the peak power divided by 2. And that's what we wanted to prove. All right. Any questions? Please let me know. Okay,
Sir, could you explain the part in purple again?
Purple. Okay, yeah, why not? So what I've done is, this is the formula I just taught you, right? There's no issue with that, right?
Yes, sir.
Suman, can I write this as V naught square under root over under root 2? It doesn't really matter, right?
Yes, sir.
So square from the root cancels out, so it becomes V naught, and this stays under root 2, and this is I naught, and this stays under root 2.
Oh, okay, sir, got it.
Like that. Just a bit of mathematics there. Okay. Well, that's good that you guys understand everything. Let me know if you have any questions before I head on to the next question. Okay. Now let's see one of the questions from the exam paper, and then I'll show you some of the questions from the actual exam as well. So this question basically shows a resistor and then an alternating supply and like this. This is 1.5 kilo ohm resistor, and the alternating supply has a rating of V naught as 150 volts and 50 hertz of frequency. So this is what is happening to it. In the first part of the question, it says express the alternating voltage as a function of time. That's important. And then we're going to say, okay, it says find the instantaneous voltage and current at 0.3 milliseconds. All right, and then part C, let me write it here, find the RMS voltage and current. And finally it says part D, let's write it here, let's save some space, find the average power through the resistor. So that's the question. Now let's see what we can do about it. In the first part, we need to understand that this is basically ordinary supply, which means a sine curve, and the sine wave basically depends on voltage at time t, peak voltage, sine of basically t, theta, right? So this is what sine, any sine function is. Now what you can do is you can actually write it as V equals to V naught. V naught is the peak power, the peak voltage, sine of omega t. Omega is basically the angular velocity. And then we can further write it as V equals to V naught sine of omega is given by basically 2 pi f. So we can write 2 pi f and t. Now this is basically a general equation for any sine wave, and for this one we got to change it. So what we're going to do is, first of all, we're going to find what exactly is the frequency. So they have given you the frequency as 50. So what I'm going to do is I'm going to just change the color to, just create a difference here. V equals to V naught sine. Now instead of f, I'm going to add 50. So 50 times f is basically 2 times 50 is 100. 100 pi would be omega and times t. So that is going to be the equation we're looking for. Do you guys understand this?
Yes, sir.
So that's the general equation. If you just remember this equation, you can actually add anything and you can find it. And I'll show you in the exam. Yeah.
Yes. Is it the same as we did in harmonic motion?
Exactly, because this is also a wave, right? And that's also oscillation. So this is the same.
Right.
All the formulas of oscillations also apply here, so that's fine. Is it clear?
So the final answer is the clean one?
Yes, that's correct. For this one, right? Now, for the instantaneous voltage, we got to use the same equation. So they say you need to find the current and the voltage. So what we're going to do is we say, okay, for the voltage, I'm going to use peak power. A peak voltage was 150 times sine of 100 this, and 0.3 millisecond is 0.3 times 10 raised to minus 3. And then what we can do is we can simplify this, and that's going to give us about 114.1 volts. You can also check it. Okay, now to find the current, it's pretty simple because it's just voltage, so I'm going to use a different color for this. V is equal to IR, and I would be equal to voltage divided by the resistance, which is 1.5 times 10 raised to power 3, and the current will be 9.4 milliamperes. You can check with the calculator as well. Is it clear? So they're the simple formulas that we've been using for a very long time, so you have to use them here as well. Now coming to the RMS voltage, and let's try and do this. Okay, so to find the RMS voltage, first of all, we know that Vrms is equal to V naught over under root 2. Okay, V naught is already given, so it is pretty simple. We're going to write 150 under root 2, and that should give us about 106 volts. It's pretty simple. Now the question is, how do we find RMS current? Okay, because the current is not given. Okay, so we're going to go back. We're going to see, okay, which formula that really suits us. So I have the resistance right here. I could use this formula, and basically I made this formula like Vrms equals to Irms times R. So then Irms will be equal to 106 divided by 1.5 times 10 raised to 3, because that's the resistance, right? And then I'm gonna get something like 70.7 milliamperes. Is it clear, everybody? Let me know if you do not understand this. Let me change the color a bit so you guys don't confuse two parts. Okay, done. Any questions? Today we are going to keep the class short because Gatika has Diwali and she wants to have fun. So do we. Okay, so we'll do questions about this only, and then from tomorrow we're going to talk about rectification, which is a big part of this chapter. Now it says find the average power through the resistor. So that's pretty simple. There are a couple of ways you can do this. Basically, if I were you, I would use power average is equal to Vrms times Irms. I would use this. But because now we have Irms and Vrms, so we can also use power equals to Irms whole square times R, because we have the resistance. Or we could also use Vrms square over R. So whatever suits you, whatever you remember, just use it. Let's try something different. Okay, so let's do this. So you can check if any of these answers basically give you the same different answer, but it would be the same. For this one, power average will be Vrms is 106. I'm going to take a square of it, and then I'm going to divide it by 1.5 times 10 raised to 3. It would give you exactly about, I think, 75 watt, 7.5 watt. Okay, and you can do the same for all others. It would also give you the same answer. You can check on your own later. Any questions, please let me know. So this chapter is like pretty easy. You just need to know V is equal to IR and power formulas and energy, and that's all you need to know. And the new ones, that Vrms were under 2, that's just to the peak power. Anyway, now let's move on, and if you guys have copied, I just wanted to show you a couple of questions here before in about 7 minutes we close the class. Okay, Raman, everything is clear? And Abdul Moiz?
Yes, sir.
Okay.
Yes, sir.
Alright, so let's move to, this is AS. I wanted to move to A2. Where is it? A2. characteristics of current. Okay, that's fine. So this way, this question, this is rectification, we'll do it, don't worry. Now this is the question I want to explain to you. All right, and it's pretty simple. It is exactly like we've been doing. So for the very first question, if you look at it, it says explain what is meant by uh, RMS value of an alternating voltage. Okay, anybody wants to tell me that? I'd love to hear your opinion about it. The ones who have actually been here from the start. Yes, Gatika Suman. Okay, in a case if you forget about it, please write this definition that you should
So
say.
is it that when steady state DC equivalent voltage or current?
Yes, so it is the steady state voltage, right, or current that produces the same power as the alternating voltage. Okay, now
So first I should write DC, right?
steady state DC voltage, you can write that, it's fine. Now in case you forget about this, because this is a difficult definition, you can just tell what RMS really is. So I told you before as well that RMS basically means you have to go backwards. So you have to square something, then you have to take the mean, and then you have to take the root, right? So if I were you, I would write that if an alternating voltage is first squared, right? So basically I'm explaining what it means. Squared, then averaged, right? Or you could say mean, and RMS value, and RMS value will be when this averaged value, when square root of this average value is taken. This average value is taken. So that's how you can just explain what RMS means. It will give you the full mark. Okay, so there are two ways you can always remember the definition, or if you're stuck you can actually explain what each symbol and how it is taken. You have to move backwards. Now the real question basically starts from here. Now this is the equation. So we've learned the equation. The basic equation is, if you remember, the equation was V equals to V naught sine or cos, whatever it is, 2 pi ft. That's what I've taught you, right? Now,
Yes, sir.
if I say, okay, for this alternating voltage, determine the peak voltage. Can you guess from comparing these two, which is the peak voltage here?
220.
220, exactly, because V naught is this one. Then says RMS voltage. Now to find RMS, what you do? RMS is equal to V naught over under root 2. So you simply pull out your calculator. Like, okay, that's not too hard. 220 divided by root of 2. So that's going to be 156. Do you guys understand this? Now, can you also find the frequency from comparing this?
$60.
Yep, that's 100% correct, because then 2 pi f will be equal to 120 pi. Cancel pi, and f will be 60. Easy, right? So these questions are so simple if you just remember this particular general equation. Okay, now, so it says the alternating voltage is applied across a resistor such that the mean power output is this. So we have the average power, which is 1.5 times 10 raised to the power 3. Says calculate the resistance of the resistor. Now that's pretty simple. Do you know what is the formula for average power with respect to voltage? Because we have the voltage and resistance. Anyone?
V squared over R. VRMS squared over R.
VRMS square over R. Exactly. So power average was 1.5 times 10 raised to the power 3. RMS 156 whole square and R. So what you get is 156 square divided by 1.5 divided by 10 raised to the power 3. So that's going to be 16 ohms. As simple as that. Do you guys like this chapter already or no? Oh, this reminds me of O levels, electricity is that simple if you just follow 2-3 formulas. Okay, Suman, everything is clear. Gatika, Ramin.
Yes, sir.
Okay, so I'm gonna see you people tomorrow, and can we start the classes like a bit early, like 6:10 Pakistan time? That would be 4:10 for some of you and 5:10 for some of you. What do you guys say? Just 10 minutes behind.
Yeah, I'm okay with it.
All right.
We started 5:10 already.
Yeah, but the official time is 20, so I just wanted to make it clear. All right. So see you then. Have a nice day.